Good afternoon or good morning, and thank you for joining us for today's webinar, our NVMe Q&A. We're here today with Tejail, and this is Actual Tech Media, and we are very appreciative that you decided to join us for today's Q&A event. This is a little bit of a different kind of event, but before we get started, let me introduce your speakers. First of all, we're happy to have Gokul Satyakama, who is the Director of Product Marketing for Data Center Systems at Tejail, a Western digital company. Gokul, thank you for being here today.
Thanks for having me, Scott.
And I'm Scott Lowe. I'm the CEO of Actual Tech Media, and I do a bunch of other things as well. But I don't want to waste a lot of time on that. So let's get into what we're going to do. This is the ultimate Q&A event. All of the questions that we're answering today have come from you, the audience. On the registration form for this event, we asked you to tell us what question you have, your burning question about NVMe. We've taken those questions and we've distilled them down to the ones we think will be most interesting to the audience. And also, they made sense. Some of them were a little bit weird. We couldn't quite figure them out. But the questions that we're asking today have come from you. There are no canned questions being used in today's event. Throughout this event, we're also going to share the results of a recent NVMe survey that Actual Tech Media conducted on behalf of Tejail. We'll share some of those results. At a date in the future, you'll be able to download the full report from Tejail. At the very end of the event, we're going to give away a $300 Amazon gift card to one lucky winner. Let's start with basically the kinds of storage people are using in their data centers. If we look at the whole market, running from cloud-based storage to disk-based storage to hybrid storage arrays to all-flash systems and beyond, we're looking at the fact that people are using a mishmash of everything, basically. The red indicates people that are using all-flash storage systems in some way, shape, or form. This might mean that they're all-flash completely in their data center. This may mean that they are using an all-flash array of some kind in their data center. But you can see that 30% of these respondents are using all-flash. Now, this brings up some interesting discussion points, many of which we're going to talk about today. We know flash is fast. We know flash is awesome. But traditionally, up until relatively recently, flash has also been held back by the interface and the protocols that we've been using that basically have their origination back in the days of the hard drive. So we're still using these hard drive-based protocols to manage a very different kind of media. And NVMe aims to change all that. And so that's why I have this in red, is the target of this is really flash-based and other types of solid-state media based storage systems that are emerging on the market. And also, one of the things I want to mention to the audience before we continue is if you have additional questions, please ask them in the GoToWebinar control panel. We will be taking questions throughout the event in addition to the ones that we gathered on the registration form. So when we start to talk about storage performance and where we're seeing storage potential, storage problem potential, we asked our audience, our respondents, where do you see the most actual or potential for storage performance bottlenecks? And you can see that 43% of people said the media itself. Now, we know that when we start talking about hard drives and things like that, that yes, there's potential for the media being a problem. And even with flash in certain situations, the media can be a problem. But typically, we don't necessarily believe that in a flash world, we're going to see the media itself becoming the bottleneck, at least not right now. As always happens, though, technology continues to advance, and we will ultimately expect to see that media becomes a bit of a choking point. Now, as we dig down into that a little bit, though, we wonder if people say, hey, it's the media because I'm not able to get my data fast enough because of the interface that I'm using on the media that I currently have in my data center. So we want to make sure we understand what that looks like. But so understanding where bottlenecks happen is really important, understanding what you can do to fix potential storage problems. So we're going to jump right in, and we're going to start with the basics. So these are some of the questions we got from our audience. We have lots more coming, but the very first question that we got from the audience is, what is NVMe? I'm going to ask Gokul to help share his thoughts on this. And while he's talking, I'm going to put a poll question up for you to answer. So Gokul, what is NVMe anyway?
So Scott, in a modern system today, you have multiple cores of CPU, DDR, SDRAM for memory, a solid-state drive for storage purposes, You may have graphic cards and so on and so forth, and even a keyboard and mouse for interaction with that system, right? So computer buses basically allow you to move data from all these devices. So NVMe stands for non-volatile memory express. And NVMe is a device interface specification for accessing non-volatile storage media over the PCI Express bus. Typically, or in legacy storage system, you're using a SCSI device interface with SAS bus or a SATA bus.
And that's, oh, go ahead.
And the acronym NVM stands for non-volatile memory, right? Which is commonly in flash memory that comes from solid-state drives.
Right, and so the purpose of this was basically to solve some of the inherent limitations that we found in storage architectures that were related to carrying over basically what used to manage hard drives, SCSI and all that good stuff, the SCSI command queue, all the massive number of SCSI commands that there were out there. And it's a simplified and refined protocol designed solely for non-volatile memory, correct?
Correct. Correct.
Now, this stuff doesn't typically happen in a vacuum, and that leads us to our next question, which is, what is the group that's responsible for managing the NVMe specifications? Is there a working group out there somewhere that is making sure that all this stuff happens in a way that is consistent across the industry?
Yes. So the initial non-volatile memory emerged from a Intel Developer Forum in 2007. And in March 2014, a group incorporated themselves of becoming NVMe Express Inc. And this particular consortium includes over 65 different companies across the industry, major storage vendors, major chip vendors, and so on and so forth. And Western Digital, which Tejal is a part of, is one of the key founders of this consortium. Very good. We have lots of people from lots of different organization sizes in our audience today. I wanted to share that with the audience. We have lots of people from smaller organizations and lots of people from large organizations. So if you're here to learn about NVMe, you're in very good company. So when we look at NVMe as a technology, it's competing with something. It seems like it's competing with legacy for the most part. But are there other things that NVMe is competing with? And what does it replace? It replaces AHCI and SATA and all that stuff, but what else does it do for us? It basically gives us the performance that the solid state or flash was actually built for, right? As an example, when you're talking about SAS, the throughput for SAS with SAS 3 is about 1.2 gigabytes per second. But when you're talking about PCIe speeds, you're talking 10 times more performance that it can drive through that bus. So what NVMe allows you to do is increase your performance and lower the latency for your application environments. And one of the ways it does that is, I mean, if you think about legacy storage, you think about a hard drive, for example, or even, a flash drive that is using, legacy technology, there's this concept of queues and then how deep that queue can be. And in the world of legacy storage, we had a single queue that was pulling data off a disk, which made sense because you could only really easily get to 1 bit at a time on rotational media to pull it off and bring it back to the controller for handling. Now, in the world of flash, there are no such limits. There's no physical, mechanical arm that has to go out and grab data. It's all electrical. And so really, when you think about it, all of the bits that are on the disk are immediately available and potentially could be brought back through the storage controller to the host. In the world of NVMe, we're looking at 64,000 potential queues, up to 64,000 depending on the implementation. So we can grab that much more data at once than we could with a
more of a legacy interface. So we have way more ability to pull data simultaneously from storage, and we also can have up to 64,000 commands in each one of those queues. So we can pull a massive amount of data off media far beyond anything we could do with rotational disks and the sorts of protocols and interfaces we're using with those kinds of disks. Do you have any thoughts on that, Gokul?
No, you're absolutely right, Scott. I mean, the whole SCSI protocol was built for rotating media or hard disk drives. And in the age of flash media, we needed a different protocol to transport mass amounts of data from CPU to storage and memory and so on and so forth.
And this is one of the reasons, as we look at, solid state media, people may think that the media is holding them back, when in reality, it's the controllers that are accessing that media holding them back. Because they're only able to, basically use one straw to get the data off the disk, when in reality, they're trying to drain a swimming pool with a single straw. Now we can use 40 fire hoses instead to drain a swimming pool, or fill it if you want to. So there's lots more opportunity for data reads and writes to happen very, very quickly. And one of the questions we just got in, Gokul, is it 64,000 per disk or per array? I think it's per. It's the controller is the limiting factor there, correct?
That is correct.
Now, when we think about workload performance, I mean, I wrote an article a while back called, latency is really the king of performance metrics. It encompasses all the other performance metrics that matter. I mean, how much throughput are you getting? How many IOPS are you getting? It's all reflected in how quickly an application is able to respond to a need that arises. And when you've done your testing with NVMe, what kind of performance differences from a latency perspective are you seeing, and what can people see with NVMe? Obviously, it's going to be workload dependent, but what are some of the common things people see by moving from a legacy environment to one that's based on NVMe?
Very good question, Scott. I mean, when we are talking about performance, it's always a combination of latency and IOPS, right? And with when we measure flash with, let's say, a SAS interface, we are measuring at 1 millisecond latency and figuring out how many IOPS we can drive. But when we talk about NVMe, our latencies are going to be in the microseconds, 100 or 200 microseconds, and we will deliver performance, more performance or more IOPS at that 100 or 200 microseconds. We haven't profiled it yet, but it definitely will be more than the SAS-based SSD technology. But one thing to note, Scott, is that today the applications might be the bottleneck to a solution, because most of the applications that were delivered, or legacy applications that were used, have incorporated wait times within the application environment, and because of this, some people will have to go back and take those wait times out of those applications in order for them to utilize the performance of NVMe technology.
It's one of the interesting things that always happens with any significant advance in technology is it seems like that's where you expose the other bottlenecks that are inherent in the system. Clear one, another one pops up somewhere.
Exactly. It's like whack-a-mole, right, Scott?
It really is. But it's a good game of whack-a-mole in this case, because we have. If you look at what you're able to achieve with what we've done in the last few years, it's pretty incredible. So
that's true.
We wanted to ask our audience on this survey. What kind of impact they think NVMe has on overall storage performance, and you can see here that I've got to hide a window because I can't see it. We actually asked this to people who already have adopted NVMe, and some who have not adopted NVMe have actually responded to our survey. So the ones who have said that they believe that NVMe will have a major positive impact on performance, 53% of those that have direct experience with NVMe in some way, shape, or form, either they've adopted it or they've worked with it in some way, say that it's going to have a major positive impact. People who are either aware of it or may not have experience with it don't have quite as high a feeling about what they're going to do from a performance perspective. Now, it flips when we talk about moderate impact on storage performance. So it seems like people understand that it's going to do something for them, but those that don't have direct experience, 61% of them say it'll have a moderate impact on storage performance, and those that do have experience believe it'll have moderate. And then we have a few that say that they don't think it'll do much of anything. And again, we haven't cleaned up all of the survey responses yet, so we'll have to go through those in more depth to find out what their thoughts are on NVMe as a whole. But I think this is important to understand here is the people who have experience with NVMe have a very high opinion of what it's able to do for storage performance and workloads. So we wanted to also include some questions that at first glance may not make a whole heck of a lot of sense. But there's a reason that we're asking them, that we're actually bringing them on today's event, because we want to also make sure that people who are looking at NVMe understand what it really is, and more importantly, what it isn't. So one of the questions that came in through the Reg form was, is data protected in the cloud with NVMe? And the answer is maybe, maybe not. It really depends on what the overall storage architecture is. One of the things to bear in mind is that NVMe has nothing to do with the cloud. NVMe is a protocol standard. It doesn't have anything to do with media. It doesn't have anything to do with the cloud. So if you're thinking about this as a cloud play, your cloud provider might be using NVMe, your on-storage or on-premises storage may be using NVMe, but it doesn't have anything to do directly with the cloud. And I'll let you take the next one. The question is there an NVMe equivalent to RAID?
No, just as like you mentioned for the previous answer, Scott, is NVMe is a protocol standard, and it has nothing to do with the resiliency of the system, or in this case, RAID groups or RAID technology. The protection from a data perspective is delivered by storage systems like Tejas IntelliFlash, which builds in a data resiliency within its system, so it's always available and it's always the same data that you wrote to the system.
We have another question that came in from the audience that I think is a good one, Gokul, and I'll let you take a stab at this. Are there different kinds of NVMe? So does it matter what brand it is? I mean, the answer is it's a standard, but the vendors have some leeway into to what degree they can adopt certain portions of the standard, correct?
Correct. Before the standard became available, there were different companies implementing their own versions of NVMe. However, since NVMe has come on board, vendors like us and other vendors like Intel and Samsung and so on and so forth have chosen to use standards because it's easy for us to plug and play in an infrastructure environment. So it's from a customer perspective, I'd advise them to use standard technologies, because when it's proprietary, you're locked into a particular vendor.
Excellent. So our next question that we have from our registration form was, how does NVMe compare to other technologies in terms of direct cost? Now, I think this is a hard question to answer, because if you think back to your storage financials spreadsheet, there's two different ways you can look at storage cost. One is on a capacity basis, and second is really on a performance basis. And it depends on your workload on how you're going to look at these things. So if you have something that has high capacity need, but maybe not a lot of performance need, cost per gig is going to be your driving factor. If you have an application that just demands massive levels of performance, but capacity isn't as critical, cost per IOPS might be a more important factor. So comparing NVMe to other technologies in terms of cost can be difficult without understanding what kinds of underlying workloads you need to support. But Gokul, what are some of your thoughts on NVMe compared to some of the older interfaces and technologies that we have in place?
So it's a very interesting question, Scott, because everything in terms of cost boils down to supply and demand. So if if the supply increases, obviously the prices will keep coming down. So with this new interface, if there's a huge adoption in the marketplace, in the storage technology marketplace, we will definitely see, the prices of NVMe technology, NVMe SSDs, as NVMe storage arrays, and so on and so forth, will become parity in a few years when demand and supply attains equilibrium.
Another question just came from the audience, which I think is important, is for migration purposes, can NVMe coexist with SAS, serial attached SCSI in this case, I think is what he's talking about, not software as a service, in a more traditional environment? And the answer would be sure. It just depends on what the host can do at that point, correct?
That is correct. So it's two different buses. They can definitely coexist. But my question is why? Why would you want to do that? Unless you want to have some legacy applications in that technology and don't want to migrate over, which is perfectly fine. But these days, you can definitely use NVMe in the context of legacy applications as well.
And the person that asked the question said that it was mostly around migration purposes. So it sounds like it's a short-term interim period that they'd be interested in having coexistence while they're moving the applications from older storage to newer storage.
Absolutely, yeah.
Now, another question that really doesn't have a lot to do necessarily with NVMe, but I think it's important to help people understand what NVMe is and isn't, is what are data retrieval options in case of hardware failure? They're the same as they are with any other media. Because again, the media itself is still flash, or it's still whatever it happens to be. So at that point, if you've had a hardware failure that's resulted in your inability to access the media, you'll be sending the media itself to a data retrieval company to take care of that. Gokul, do you want to add on to that at all?
Yes, I mean, think of a drive, right? That internally it has flash memory to provide persistent storage. The connector is going to be different for SAS or SATA, just like SATA and SAS are different. This is going to be an NVMe connector. So that's the only change, but underlying it's flash and persistent storage on flash media.
Now, the next question I think really is actually an interesting one, because the answer to this could be negative, depending on how you use the media. The question is, what is the average lifespan of an NVMe drive, both under normal use or if it were being stored with data on the shelf? Now, again, the longevity of the media is going to be determined by the media type as well as how that media is being used. Now, let's say it's flash, for example. We have this concept of program erase cycles or drive writes per day with flash. Well, with NVMe, you can all of a sudden massively accelerate the amount of data that you're writing to those disks. So you might see some wear issues potentially if you're pushing the drive past what you were able to do with older interface technologies. Gokul, do you have any thoughts on that?
No, you're absolutely correct, Scott, which is, more lanes, more data I/O means, more wear of the flash itself, correct. But we have the ability from a storage system perspective to tune the system and manage how and when data is accessed on the drive, and which allows us to increase the endurance of the particular drives within a storage system. So we manage that as part of our data services tier to deliver that endurance for the longevity of the system.
And we just got a couple questions in from the audience. The first one is, can a hard drive use NVMe? And the answer to that is no, correct?
Correct.
The next question is, given that it's slightly newer technology, is NVMe widely adopted by all major operating system vendors? And are the drivers available and reliable? You know the answer to that?
Yes, so it is readily available. Most operating systems, if you're looking at a server connectivity, let's take a Microsoft Windows Server or Linux, the drivers are already within, as part of the operating system distribution. Now, if you're thinking about storage systems like the Tejas IntelliFlash, we manage it with a proprietary operating system and a firmware within our system that allows us to talk to NVMe SSDs. So from your perspective, you are delivering data to us with traditional storage protocols like NFS or CIFS or Fiber Channel or iSCSI.
Very good. Let's move on to some more results from our survey. When we talk about, what kinds of features people are looking for when they look at NVMe, what can NVMe do is the question. We know that it can be a lot faster, for example. When we look at results from people who we've asked them, how do you think that NVMe adoption is going to improve your storage environment? 47% said they think it's going to reduce latency, and 60% of people who have experience with NVMe believe that it will increase throughput. And then we have some other benefits. And actually, NVMe, depending on how it's implemented, can do all of the things you see on the screen. There's potential for lower power consumption. Obviously, when we look at increased throughput and decreased latency, that means we're probably increasing IOPS somewhere. And with end-to-end encryption, we can ultimately improve storage security. Gokul, do you have any thoughts on these results?
No, I think this is what we've also understood from the customers and prospects we have worked with, and this is around the same thing what they've told us as well.
Excellent. And we'll move on to our next set of questions. While we have these questions up on the screen, I'm going to launch our next poll. I know that you may not all know the answer to this question yet, but I'd like to ask you, in what time frame do you plan on adopting NVMe, if at all? So the first question we have to start asking is about, this is use cases. So, when we start thinking about storage, we want to make sure that we're meeting the needs of the business, and that really means we have a discussion about use cases. And so the first question we have to ask is, can NVMe be used with VMware? And Gokul?
Yes. Remember when I said you are using traditional protocols to talk between the server and a shared storage system like a Tejas IntelliFlash. So you would create an NFS data store, or you can create a VMF data store, and in the back, we will manage the interaction between the controllers as well as the NVMe SSDs. Now, if you are using host side or server side NVMe SSDs, that's I'm not too familiar whether VMware supports that out of the gate, but I'm pretty sure if they haven't already, they probably will.
And they will, yes. Now, on the next use case is, how can NVMe make data warehousing more manageable? And here, I don't think it necessarily makes the data warehousing product more manageable, but I think NVMe, depending on how, again, there's, I do a lot of consulting work, and the answer to most questions is it depends. There's lots of dependencies here, but depending on how you're using your data warehouse and how it's being operated, NVMe can have a pretty significant benefit from the amount of time it takes to actually retrieve data from the warehouse. That's not necessarily going to change the amount of time it takes to do analysis, because it's a lot that's CPU intensive versus NVMe intensive or storage intensive. But it can make your data warehouse more manageable from the standpoint of how quickly you can get data into and out of the warehouse. Now, Gokul, let me let you take the next one. Is we have lots of managed service providers out there, and they're always looking at new technologies. How can NVMe fit into an MSP, and what kind of benefits can it provide their customers?
So every customer that we've talked to has tiers of application within their data center. They have tier one that requires the utmost, which is critical to their business and needs the utmost performance. And then you go down the stack with tier two and tier three applications. So the business critical or mission critical applications of our customers, they will definitely want to use NVMe technology or NVMe based storage because they can do more analysis, more real-time work, and do a lot more operations, a lot more storage operations than what they are used to before, which means they can close their books faster, they can do more online transactions, better user experience. Think about even VDI environments where the system comes up within a matter of seconds as opposed to 5, 10, 15 seconds wait for the boot to boot prompt to come up. So there is tremendous potential in terms of how NVMe can help MSPs or any of the customers they serve.
One of the questions just came in from the audience is, when using NVMe, does that mean that you're not using SCSI anymore? And the answer is correct. That's the point of NVMe, is to not use SCSI anymore, because SCSI is a 1980s level protocol, right? That we managed to carry forward for decades. Another question from the audience that just came in is, are self-encrypting disks still supported with NVMe?
Initial foray into NVMe SSDs do not come with self-encrypting drives. However, the roadmap for NVMe SSDs include self-encryption and other features as well. The good thing about the Tejas storage is that we have access to the roadmap as well as access to the supply of Western Digital or AGST NVMe SSDs, which allows us to kind of plan when and which features we deliver to our customers.
We have a general question that's come in, Gokul, that I'm going to ask you, and I'm going to ask it in a more general way than the person did. But what are some of the security capabilities that are inherent with the use of NVMe?
Inherent security questions?
Yeah. So, like, what does NVMe provide from a security perspective? The specific question is, does it have security features like zoning or communities that define who can access the NVMe storage and things like that? But I think in general, it's a security question.
Yeah, so when you're talking about within a storage system, self-encrypting drives will definitely help in providing the security functionality. However, remember, when you connect a host to a shared storage infrastructure, the connectivity between the host and shared storage infrastructure is through fiber channel, iSCSI, NFS, SIPs, or whatever the storage protocol du jour is going to be. And the zoning and all that stuff is handled through current existing security protocols or security mechanisms that are in place. So you don't have to change anything from that perspective.
Okay. Let's move on with some of the questions we got during the registration piece. You see some of the results from our latest poll question as well. The question we asked was, in what time frame do you plan on adopting NVMe? Just over a third say no plans at present. 20% say they've already adopted in some way, shape, or form. A few are going to do it in the next few months, and then the rest are the balances over the next 6 months to 2 years. So when we look at return on investment, the specific question that came in on the reg form was, is there a tangible return on investment for NVMe in education? And again, the answer is, as it usually is it depends. It really if that educational organization has an application that demands very high levels of storage performance, then there may be an ROI. If that educational institution is looking for general purpose storage that for which capacity is the key driver, there may not be an ROI. It really comes down to what the workloads and applications are going to be that run in the environment. Gokul, do you disagree with that, or is that pretty well on mark for you?
That is pretty well on mark. I mean, let me boil it down a little bit, right? Today, in many universities, we are seeing virtual desktop environments because it's easy for universities to create these desktop environments for their students to use instead of having physical laptops or physical desktops. Now the user experience of that can be delivered in a much better way with NVMe technology because it will give you the performance like you're using physical desktop or laptop. On the other hand, it is all about cost and what cost it is going to take you to move into this environment and deliver that user experience. If it's important that you deliver this great user experience, this is something that universities or educational institutions might consider. If it's not their top priority or top goal, then they might continue to use flash or alternate technologies to deliver VDI environments.
We got an answer from the audience on a couple questions from before around security. One was there are multiple authentication methods for supporting in-band authentication to devices in an NVMe environment. The other one was there are currently ongoing relationships between the NVMe Express group and the Trusted Computing group to add additional security improvements to NVMe. So, and don't forget, what you see in NVMe today is what it is as it exists today. This is an ongoing standard. It's already gone through multiple revisions to get to where we are today, and it's going to go through lots more. And as new versions are released, we are going to see new features be added, and I would expect to see a lot in the way of security features be added to natively to storage devices through NVMe in the future.
Absolutely, Scott. Just imagine, when if you recall a few years back when SAS SSDs or SATA SSDs came out, they didn't come with all the bells and whistles as well. So, this is emerging technology, and at some point we will come up to par or even exceed some of the capabilities of SAS and SATA SSDs.
Our next question we have is, what are some of the best practices and use cases associated with NVMe? Gokul, this is something you probably talk to people about every day, so I'm going to let you take this one.
Sure. So NVMe is about delivering new experience. Think about experiences that customers haven't even thought about in terms of how the application can deliver it. So in terms of delivering that experience, some of the best practices are know which applications that are very important to your environment, and then start using NVMe technology or NVMe-based technology to deliver user experience so that they can interact with data, they can take that data and form information around it and deliver better experiences and better usage within that data set.
All right. I'm reading the next question we got from the audience here. It's a long one, so please bear with me for just a second. This gets into something we're going to talk about shortly, so I'm not going to ask it quite yet. It gets into fabrics. So our next slide talks about some of the performance, some of the ways people are deploying NVMe in their data center environments. How have they deployed it? Have they deployed it in server-based storage, or how they intend to deploy it into shared storage, NVMe over fabrics, which we'll talk about shortly, or they don't have any plans to deploy NVMe. And you can see that server-based storage right now is where NVMe is strongest, although shared storage is a very close second, which is exactly how I would expect to see this. So, Gokul, the next question is around adoption, and who do you think are going to be the early adopters, or who are the early adopters of NVMe?
So we've come across a lot of customers like life sciences and like in the life sciences industry, where they want to do a lot of analysis and everything has to be delivered in real time. So think of a real-time environment, and those are the early adopters of NVMe. So where it can be real-time analytics, real-time transaction processing, anything that want a real-time user experience are early adopters of NVMe.
Yeah, and that's one of the things we've seen, not in just storage, but across the board. I mean, we've done events and research with lots of different companies in the last few years. And this idea of taking latency out of the user experience is critical, not just in storage, but everywhere. And so anything you can do to get rid of some of that latency is going to go a long way towards helping reduce latency, the full stack latency that the user experiences when they're interacting with applications. And
yes, as an example, Scott, we have a customer that use our SSD technology, our flash, all flash arrays, and took their analysis of traffic patterns from 4 hours to 20 minutes by using flash or all flash arrays. And even that 20 minutes is too high for them, and they want to kind of get it down to 4 or 5 minutes, and they expect that the all NVMe arrays from Tejal will give them that kind of experience.
4 minutes is lower than 20 minutes, just so the audience knows. I'm kidding.
Good point.
So, Gokul, let's talk a little about the future. Let's start with the NVMe itself, then we'll talk about interconnectivity. But what do you think is the future of NVMe? What's coming next?
One word: exciting. Exciting. It is exciting because storage has. I mean, throughout this whole presentation, it's always been that storage was always the bottleneck in the infrastructure space. However, NVMe is opening up the possibilities of how data and information can be used in today's data center to do things that you've never thought of before. And I think why I'm excited about NVMe is that the storage is not going to be the bottleneck. Now it's going to be the application or the CPU. And I'd rather move the problem somewhere else than use storage as the beating stick all the time.
We have a poll question up on the screen now. It's basically, what kinds of applications are you running in your environment? If you're not running any of these, you don't have to answer the question. We'd like to understand, though, basically what kind of applications might be, candidates for NVMe for you. So if you can answer that while we continue to chat, that'd be great. Now, one of the things we haven't talked about very much, Gokul, is the fabric. And, NVMe in a host is great because it's massively low latency. But as soon as you separate the host and the storage, you have to have something that makes sense. So tell us a little about NVMe over fabrics and what that means.
Sure, Scott. So let's look at it from a simple form, right? If you look at a storage, a server, or host server, you can attach an NVMe SSD and run data on your PCI bus to get the best performance. However, not all servers can share that particular device. In order for you to provide a shared NVMe SSD environment, now you can use something like a PCIe switch, or you can use Ethernet and then use NVMe over fabric technology to kind of create a shared storage environment and serve multiple hosts. Now, alternatively, if you don't want to use NVMe OF, and if you have legacy applications that use fiber channel or iSCSI or NFS or CIFS or SMBv3 to talk to a shared storage infrastructure, you can still do that and basically from your all your hosts have connectivity to your storage. And in the back end of our storage systems, we provide NVMe technology to accelerate all those data accesses that you require from a host perspective. So there are different ways of deploying NVMe over NVMe and NVMe technology, and it depends on how you want to use the data and how you want to deploy that environment to get the best for your applications.
I mean, for people who have made significant investments in something like Fiber Channel, I mean, NVMe over Fiber Channel is a thing, correct?
Correct. I talked about NVMe over Ethernet, but NVMe over Fiber Channel is also getting some traction.
So there's also, Ethernet, Fiber Channel, and even something like InfiniBand, which would give you access to the PCIe side of things a little bit more directly, correct?
Correct.
And actually, we just got a question. Actually, it's an answer to the question in the chat. So yes. NVMe, the answer here is from someone who is working with NVMe a little bit, or maybe a lot bit. It says NVMe over Fabrics is transport agnostic. You can use InfiniBand, Ethernet, or Fiber Channel to run NVMe over Fabric. So there's lots of opportunity. This is not necessarily a situation where you have to do a wholesale rip and replace of your existing environment in order to adopt Fiber Channel. I'm sorry, NVMe. I misspoke. So now, when we think about the speed, the next question is NVMe over 40 gig Ethernet or 100 gig? Yes. I mean, you can basically do it over 10 gig if you wanted to. It just depends on what the vendor makes available. Let's see. So the question that somebody says is, do we need to upgrade our Fiber Channel over Ethernet hardware to accommodate NVMe? I don't know. You know the answer to that, Coco?
No, I don't.
I mean, you wouldn't have to upgrade necessarily your Fiber Channel hardware, or maybe software, but this is specifically Fiber Channel over Ethernet, so I don't know the answer to that question. But if you're using Fiber Channel, it should work in place, but Fiber Channel over Ethernet, I don't know the answer to that question. Sorry, folks. We're going to show the results of our poll. We have a lot of people using databases, which I suppose is not a huge surprise. A lot of people doing real-time analytics and real-time transaction processing as well. This is 60% of our audience responding. So there's a lot of opportunity for acceleration of these workloads, particularly in anything that's real-time, as we've alluded to before. So, okay, so we just got an answer to the Fiber Channel over Ethernet hardware question. So the Fiber Channel over Ethernet hardware will need a firmware upgrade, so that's verified. At the moment, though, no one has advanced support for NVMe. Oh, no one has announced support for NVMe, the Fiber Channel over Ethernet adapters. So your Fiber Channel stuff will still work, but if you're doing specifically Fiber Channel over Ethernet, at the minimum, you're going to need a firmware upgrade, but you're not going to find much in the way of adapters as it stands right now. And that's the last questions we have from the audience right now. Let's see what else we have to share with our audience. Gokul, are we ready to do if there's any more questions from the audience, please ask them. We have a few minutes left. If not, though, we will wrap this up and everybody can move on. What do you want to do, Gokul?
That's perfectly fine.
All right, we got one more question. What capacities are available in NVMe SSDs today? Gokul, do you know the answer to that question?
Yes. So in our products, we use 960 gigs, 1.92 terabytes, 3.84 terabytes, and 7.68 terabyte drives.
Excellent. And our winner of today's $300 Amazon gift card is Lynette Inman. Lynette will be reaching out to you after the event. We'd like to thank our audience for joining us today for today's event. Gokul, thank you for being here as well and answering those questions. It was sort of this was a rapid fire event, so I really appreciate you being here today.
Thank you very much for having me, Scott. And if you have any other questions, this is to the people out there. If you have any other questions, follow-up questions, feel free to contact us. We'll be more than happy to talk to you about NVMe.
Sounds good. Thank you so much, audience, and everybody have a great day.
Thanks.